Okay, in 2-2 here, you're going to have some new things you're going to hear a little bit probably. The things called exponents and powers of 10. So I want you to take a look at these problems. I have some things underlined here. I want you to study this a little bit. 10 and this 2 equals 10 times 10, which equals 100. If you can, if you're with somebody on the same lesson here, talk with them, and then what do you think the small raised number means? So talk with somebody about that. Pause the video and go ahead and do that. Talk with them quick if you can. If not, no big deal. But I want you guys to be able to talk about it and to discuss what you think that means, and then we'll come back. So hopefully you're back here. I can now. A little pause there, but this 10 to the second power means 10 times 10. So it's basically taking whatever your base number is right here, and then whatever your exponent is, and then multiplying that together. One of the big relationship things I want you to notice here is that whatever your, when you have a power of 10, that means it's a 10 right here. Whatever your exponent is, that's how many zeros you're going to have in the number. So in 10 to the second, there's 2 zeros. In 10 to the fifth, there's 5 zeros. And the number 1 stays the same right here because you're just going to be multiplying 1 over and over again, as you see here. 1, 1, 1, 1. So that's one little quick tip or thought, I guess you could say, about that problem. So in this problem here, I want you to discuss that whole 10 to the 6th that you just did. So that 10 to the 6th power right now, what do you think that's going to look like if you multiply it out? So you thought something like this. So it's 10 times 10 times 10 times 10 times 10 times 10. You're doing it 6 times. That's what this exponent means. And then here, all written out, you can see that there's 6 zeros. So that's what you're kind of looking at here. Now, your exponent is going to be that number that you see right up here. That 6, that smaller number, is called an exponent. The number right before that is your base number. All right? So when the base is 10, and it can only be 10, like this is right here. You can't put a 6 or whatever in this base area. That's just called powers of 10. They're easy to do because your first number is always going to be a 1, and then whatever behind it is however many zeros are going to be there is going to be what this number is there. Exponential notation is written just like this. That is exponential notation because you have an exponent in it. We'll get into some of the other stuff as we go here. So you can see right now you have that 10 to the 6th as your exponential notation. Products of 10 are going to be the way that you would multiply it out. And then your standard notation is going to end up being right here. So this is on page journal 41 right now. I'm going to ask you, I'm going to say some things. I want you to write those in right here. So exponential notation, I want you to put as 10 to the 5th. Put that in right here. And then you figure out the rest of these. In this one, I want you to put 10 to the 8th. And then again, the products of 10 and then your standard notation. And then in this one down here, I want you to put 10 to the 3rd and then write that out as well. You can check these once you're done with the entire journal page and check to see if your answers for your products and your standard notation are correct. This page right here is going to be a quick review. It's on journal page 42. You're looking at the very top of it. And this is numbers in expanded form are written as addition expressions. And then you can also write them a number of different ways too. So as you can see in 2,784, the 4 is 4 ones, 8 810s, 7 700s, and 2 2000s. They can also be written right like this. So your 4 ones is 4, 8 10s is 80, 700s as 700, 2000s as 2000. Now you can continue to write this and break it down a little bit more as 4 times 1, 8 times 10, 7 times 100, 2 times 1,000. Now, these are all powers, or could be written as powers of 10, I guess you would say here. So that's going to jump you from this spot over into this spot. So in your ones place now, you can write this as 4 times 10 to the 0. because you're not going anywhere. There's no 0 at the end of this, so there's nothing there. In this problem, 8 times 10, it's 8 times 10 to the first, because you just have 1 0 in that problem. 7 times 10 to the second, because there's 2 zeros. 2 times 10 to the third, because there's 3 zeros. We can only write it this way because these are all now written in powers, like the power of 10. There's only a 1 in front of it, because when you multiply 2 times 1, you get 2,000, add 3 zeros. 7 times 1, 7, 3, 0, 2 zeros. So hopefully you kind of get that idea of what that is going to end up looking like when you do this. This is going to be something that you'll do in part C on this page. You're going to have to write this in exponential notation. That's essentially what they're asking you to do here. But that expression, again, it just ends up being written a little bit different. Looks kind of, in a sense, like this when you get crazy with it. But when you do your assignment, it'll look a little bit different. So down here, this is that exponential notation part. Standard notation, again, is going to be just your typical answer. And then here is that exponential notation where you're going to take the powers of 10. So you got to look at your beginning number and then how many zeros in it, that sort of thing. So I think you'll, this will be a little bit interesting to see how you're going to do with this one, because it's kind of confusing, but you got to really think about the powers of 10.